This is the short version of practice problem number 3 from lesson 4, Making the Moves, unit 1, rigid transformations and congruence. There are 3 parts to this problem, each a different rotation of this quadrilateral A, B, C, D, but all of them a rotation around this point right here. Point B is the center of rotation. So the first part is a 90-degree rotation clockwise. That means in the direction of a clock. So it's going to rotate this way. 120 degrees clockwise, so once again in the direction of a clock, so it's going to rotate this way farther, 120 degrees, and 30 degrees counterclockwise, so 30 degrees in the opposite direction of a clock, so it's going to rotate this way. This is a 90-degree rotation of A, B, C, D around point B, and there's several ways to do this. One way is to use tracing paper, so to trace this figure and rotate it using a protractor to measure 90 degrees. Make another copy and cut this out. I'm using the app Docere, so I'm drawing everything in Docere, and I'm going to make 3 concentric circles with the center at B. So here's one circle, and this is the circle that point C is going to travel on, 90 degrees clockwise. Another circle, D is going to travel on this circle, 90 degrees clockwise. And A is going to travel on this circle, 90 degrees clockwise. I also want to look at point D. I want to look at this line segment so I can measure 90 degrees. So looking at this diagonal from B to D. In Docere, I can use a protractor to draw a 90-degree angle. So here's that 90-degree angle using the protractor. And now I can take this angle and lay it over that quadrilateral ABCD. So here's that same 90-degree angle, and I took the vertex of that angle right here and placed it on point B because B is the center of rotation, and I lined it up with this side, BC. And so now this is a 90-degree rotation clockwise, so in the direction of a clock, and C is going to travel from this point here to this point here, and that is C prime, 90 degrees. Next, I'm going to line up that 90-degree angle with side BA and look at the rotation of A 90 degrees from A to A prime. And finally, I'm going to look at the rotation of this diagonal BD so I can see point D rotate 90 degrees clockwise to D prime. And get rid of all the circles, connect the points, and this is a rotation of this figure to this image, A prime, this should be B prime, C prime, D prime. And if you look at this angle right here, A to A, you can see that's 90 degrees. Look at this angle right here, C to C prime, that's 90 degrees. And if you can visualize D to D prime, you can see that that is also 90 degrees. So now we're going to rotate that same image 120 degrees. So now it's going to rotate farther than the 90 degrees. So it's going to go farther in this direction. But first, we need a 120-degree angle to use to measure that rotation. So once again, I'm using the protractor in the app Docere, and I'm drawing a 120-degree angle. So here's 0, here's the vertex, and here's the 120 degrees. So this angle is 120 degrees. So I'm going to copy that angle onto the figure and use that to measure those 120 degrees. So here's the same figure once again with the same concentric circles, meaning that B is the center of each of those circles. And now we're going to look at a rotation of this figure 120 degrees. So here's that angle with the vertex at point B because that is the center of rotation. And so A is going to move along its circle 120 degrees clockwise to A prime. Point D is going to move 120 degrees along its circle clockwise to D prime. And I'm using this diagonal BD to see that. And C is going to move 120 degrees along its circle to C prime. Again, I'm using that angle 120 degrees. The vertex is at B. The rotation is 120 degrees clockwise. Get rid of all the circles, connect the points, and this image now has rotated 120 degrees. And now look at A, to B and B to A prime, you can imagine that that's 120 degrees. Look at C to B, B to C prime, again 120 degrees. And if you can imagine this diagonal B to D and B to D prime, that is also 120 degrees. And finally, we're going to rotate the same quadrilateral, but now in the opposite direction of a clock, 30 degrees. So now we're going to go 30 degrees this way. So first we need a 30-degree angle so that we can measure those 30 degrees. So again, here's that 30-degree angle right here, and I'm going to take this angle, copy it onto that quadrilateral ABCD and measure 30 degrees counterclockwise. So here's that same figure, same concentric circles. Here's the angle right here. This is 30 degrees, and so this is showing the movement of A 30 degrees counterclockwise to A prime, 30 degrees. This diagonal BD, so point D, is going to move along this circle 30 degrees counterclockwise to D prime. And C is going to move 30 degrees counterclockwise along this circle from C to C prime. Get rid of the circles, connect the points, and this is image A prime, B prime, C prime, D prime, rotated 30 degrees counterclockwise. And if we compare that to the other two, so this is 30 degrees counterclockwise, this is 90 degrees clockwise. Look at A to A prime, you can see that's 90 degrees, and this is 120 degrees clockwise, A to A prime. So let's do that one more time, just looking at A to A prime. This is 30 degrees counterclockwise, 90 degrees clockwise, and 120 degrees clockwise.